Welcome to qnawire.
Okay, let's go ahead and solve this problem. It's asking us to evaluate the double integral of xyz through s. And what it basically means that this is a surface integral with the input being xyz. So it's different from a flux integral, so please be careful with that. The way we integrate these things, we use this formula. What's important to remember here is that all we need to do is to represent z as a function of x and y. And then when we figure out what the normal vector is going to be, because of the way how z works as a function of x and y, it just ends up being the square root of 1 plus g sub x squared plus g sub y squared, where g sub x and g sub y respectively represent the partial derivatives of g of x comma y. So we're going to try to utilize that function. And I tried to draw to the best of my abilities of what the surface would look like. It's basically the contours are going to be a bunch of parabolae, and it's going to be like a blanket where you lift up one end right here up 4 units upwards. So that's what I want you to imagine what it looks like. Okay. All right, so let's start the calculation. So I one thing that I need to note here is that although the question asks you to find the exact value of this thing, it's asking you to find the expression of the value, because the value itself, the integral itself, is not something that we can actually evaluate by hand. So as a number, I will give you an approximation, but the expression that gives you the exact value is basically what we're going to look for. Okay, so here we are given that z is x squared y squared. So I'm going to call that function g of x of y, x comma y, which is x squared y squared. Okay, so here we know that g sub x will be 2xy squared, g sub y will be 2y x squared. When we square these expressions, we will get 4x squared y to the fourth and 4y squared x to the fourth. So the expression that we get for the square root of 1 plus g sub x squared plus g sub y squared can be rewritten as the square root of 1 plus I can factor out a 4x squared y squared from both of the g's of x squared and the g's of y squared, and the inside will just look like this. Okay. All right, now xyz, the expression, you just need to represent z in terms of x and y as well. So going through the expression, we will have x cubed, y cubed, times the square root of this expression. Now we want to figure out what the projection is going to be. This one is quite simple because we are given that x is between 0 to 1, y is between 0 to 2. So the projection that I drew right here is just a simple rectangle. So the limit of integration is quite simple. The x goes from 0 to 1, y goes from 0 to 2. So it'll be dy dx. Because I see an x squared plus y squared, I also considered using the polar coordinate form, but it really doesn't make anything any simpler. So I will just say that this is a good enough expression to be the exact number of this surface integral. Okay, now when you use a calculator, you will approximately get a value of 4.92429. And all of these surface integrals are quite complex, and it's very rare to actually be able to solve for the exact value by hand, so do not worry about that. If you can, the problem is very artificially made so that the numbers are going to work out nicely. Okay, so this is how we solve these kind of problems.